There's a temperature of coffee is modeled by a differentiable function C, where C of t is measured in degrees Celsius between this range 0 to 12. So there's a table here, minutes, the time is given x values, and the function of x, or the C of t, which is the y values, is also given. So the temperature, as you can see, is decreasing over time. So what we have to do with A is essentially we have to find the C prime of t, which is the instantaneous rate of change at 5, using the average rate of change of C over this interval between 7 and 3. Okay, so what is the average rate of change formula? It is the slope of the secant line, same thing. It's essentially y2 minus y1, x2 minus x1, or you can also say C prime of x is the temperature function at some point B minus the function at some point A divided by B minus A. So this rate of change is delta y divided by delta x. So then we can go ahead and plug in those numbers. Those numbers are given in the table right here. So we can say the temperature at B, which is B value is at 7 times 7 is given to be 69, and then and at A is given to be 100. A is given to be 85. So what we're going to do is, in order to calculate C prime of 5, which is at instantaneous rate of change here, we're going to plug in the numbers. The function at 7 is 69 minus the function at 3 is 85, and divided by 7 minus 3. That's the x2 b minus a, or the x2 minus x1. So essentially what we have received is the instantaneous rate of change of the slope at C prime of 5 is -4. Okay, so that is a close approximation based on the average rate of change. And also the units of this, as asked in the question, are basically degrees centigrade per minute. Okay, so we can write degrees centigrade per minute are the units of this, and the approximation of the instantaneous rate of change at C prime of 5 at this area, at this spot, is -4 degrees Celsius per minute. Okay, that's the first part.